GM. Today we're going to go over a more complicated example of using stylus. We're going to learn about inheritance, some of the more complex features that you have available to you in the Rust SDK in particular. We have another video on how to get started. You can either watch that or go through this gentle introduction here, which links to various things as well as our quick start. And we also have an SDK feature overview that goes through like all of the different features of the SDK. So, I won't go over all of this today, but anything that you're looking or that you want to like figure something out about, this is a pretty good resource for it. But today we're just going to go over like an example program that touches a few different things. So, I'll presume you already have Stylus installed. You've got the Cargo Stylus tool, and you've been able to create the Hello World program that we gave, the one with like counter project. We're going to do something very similar. So in this terminal here, I'm going to start a new project. So recall with Cargo Stylus, you can say Cargo Stylus and then new for the fact that we're making a new project. And I guess we're going to name it tutorial because we're making a tutorial together. So that's just created a new folder which has the project in it. And if we just take a look around here at the various things, it's a standard Rust project, and there's a source file that currently contains just a main. So yeah, very standard stuff. Every time you run this tool, it'll give you that exact thing. And now we're going to together, though, open it up and actually start writing some code. So I'm going to go open up Emacs real quick. We're going to navigate over there. So I put it in /temp. Okay, so I called it tutorial. Okay, so this is the program that you are always given when you start up a new project. It's just the simple counter. I know Raul has a great video where he goes through this, but we're going to probably keep none of it aside from the cargo.toml. Recall that there's a cargo.toml that every project comes with, and it includes various configuration options, right? So you've got like your dependencies, you've got the various features that your thing has, all those nice things. You can look up the Rust docs on that. We'll just keep this pre-configured, so there's nothing like special we're going to add to it today, but the Cargo Stylus tool is nice. Like even if you're starting from scratch and you intend to delete everything in this file, having those configs in the right places and just ready to go is great. Another config, by the way, that matters is this .cargo config. This is pretty advanced, but you can do things like set how big you want the Rust stack size to be and stuff like this. Not that you need to really dive in too much into the various options for that today, but the important part that I just want to note is that when you use the Cargo Stylus tool, it just like puts everything in the right spot. Okay, so we have this simple counter program. I'm going to delete most of it, but just keep a few things and explain it. And then we're going to together like write a program that just does something a little more complicated. So I'm going to keep up at the top this little conditional compilation thing. We don't have to go super detailed into it, but basically what it does is, it allows this program to not have a main. So most Rust programs are going to have a main, and that's like where your program starts executing. It's often called your entry point, right? That's a little more technical, but or how exactly that all works, but with Stylus, what's kind of fun is we actually don't have a main. Instead, the entry point is decided by the virtual machine, and there's a special symbol you need to export to do that. Thankfully, the SDK figures all this out for you, right? But a quirk is that we have to have this config line at the very top just to make sure that that all works. Now, the reason this thing is conditional, which is what this attribute thing is and the whole not. The reason this thing is conditional is this. When you go to export your ABI, recall with the Cargo Stylus tool, you can just type like Cargo Stylus export ABI. Well, how that thing actually works under the hood is pretty interesting. It goes through all of the various macros. So recall we have this like sole storage macro, this entry point macro, the external macro, and various other things that we're going to do today. And what's rather fun is while normally those have the functionality of like creating methods and storage and all of this, right, in your entry point, when you actually use the export ABI feature, what it does is repurpose all of those macros to generate the actual code necessary to print out your methods, your interface, all that stuff to the console. So literally what we do is through conditional compilation, change what all of the macros in the SDK do. So I just thought that was kind of interesting and give some light as to like why we would have this line at the very top. You're able to configure it further. If you're pretty advanced, you might decide to turn off the standard library, or rather not use it. And in this case, like, you know, perhaps in the effort of reducing binary size, you don't have to import too many things, right? You can actually restrict yourself to just the things in what Rust calls core or alloc. We do need alloc. That's the allocator that gives you access to heap and stuff. So that's what this first line does, and I just wanted to give some explanation into it. Another thing that we tend to do is change the global allocator. So the global allocator basically lets you decide how malloc and free, those are the terms we would use in C, happen in Rust. So basically, how do we allocate things? How do we free things? What specific algorithms to use under the hood for that? This stuff, the implementation details don't particularly matter, and usually you would just not have this, and we could indeed just delete this, right, and everything would still work, but it's kind of nice to use a simpler allocation policy when working in WASM, and the reason is just that binary size constraints are pretty tight, and it turns out that wealloc is very, very small, so that means that you're not like pulling in as much code you know, to actually have your stylus program be able to, well, allocate in free memory. So that's what this line is for. Feel free to keep it or leave it, but I just generally keep it. And we're going to explore in the future other allocators and stuff. But then we have some imports. It's very standard. We'll probably just, you know, add some imports later. And then everything else, I'm just going to delete all that so that we're starting from a relatively blank slate. So all we've really done is got conditional compilation, whether or not we're going to have a main function, whether or not we're exporting an ABI and repurposing all those macros. We're going to have the you know, global allocator selected to something that we like. Feel free to pick your own. And now we're going to actually start writing a program. So every program starts with its storage definition. That is like, what state is this contract going to carry? You could choose to not have any state. This is very allowed. But most of the time when people write really interesting dApps, they're going to want to have some kind of thing that they keep in storage. Now, that's not to say you can't write interesting dApps without storage. And in fact, some of the most interesting ones, the cryptography or algorithms or, you know, very specific solely compute things, those are the kinds of things where you wouldn't want storage. But we'll just assume for the purposes of today that we do. So there's two ways to declare storage. You can either do it in Rust. So the way that works is, I mean, obviously both of these are Rust, right? But you can either use Rust-like syntax. So you would just decide, I'm going to create a struct that represents the, you know, top-level storage object for my contract, I guess we'll call it. And, you know, it can have various things in it, right? Now, the things it's allowed to have in it, if it's going to be storage compatible, have to be storage types. So there's various storage types that you can import. I'm going to start by just saying I want to abide by that and have Solidity storage, or have a Solidity storage representation for everything that I'm doing inside this contract. So every field that I add is going to have some kind of Solidity equivalent form that it writes to the persistent storage in. How that works is a little involved, but What's really cool about it is it's identical to Solidity. So that means if we write a bunch of fields, the orders and slots and all of that stuff are going to be the same. So we imported this macro, and now we're able to start adding entries to it. Now we could just decide we're not going to have anything inside it, right? But that's up to us. One thing, by the way, now my editor just decided that it was going to use this particular import. I actually prefer to just use the prelude. So this is pretty common in Rust. You have a prelude where you just import everything under it. So the prelude, if we jump into it, is kind of nice in that it exports all of the various traits that we care about. So there's like macros and everything else. You actually notice it exports every proc macro. And if we jump to the proc macros, you'll see here, like, oh, hey, there's that Solidity storage. There's some of the others we're going to look at together. So yeah, backing up here, you'll see that this prelude crate, or I say crate, I should say module. So this prelude module has various types and traits and mechanisms for writing your contract. So, okay, so this is Solidity storage, and we could just start typing out stuff like, I could say maybe I'm going to have an owner, and this owner is going to be a storage address. Okay, and now what's really cool about that is this contract object is able to store things persistently to state. So, and it actually does it exactly as one would do it in Solidity. So the exact same way a storage address, the exact same way an address is stored in the EVM state trie, through the Solidity compiler, we have that in Rust. Now, because that, mapping exists, just the fact that like every Solidity type has an identical representation, it's actually sometimes nice to, instead of defining your types in a Rust-like syntax, to use a Solidity syntax. So we actually have this other macro called sol storage, and it lets you define a series of structs. So I could say like, we'll just do the same thing. I'm going to define a contract, and it's going to have an owner. But because this is Solidity, or rather Solidity syntax, you instead write it like this. So I would say that my address, this owner field has the address type. And of course, you wouldn't want to name two things contract, so you can't have both of those at the same time. But what's really cool is you could have other sub pieces of storage, right? Like I could have some substruct, and maybe it has a field called flag. That's a bool, and I could actually go use that thing. So I could say, I suppose, substruct. And then I guess sub, and that substruct is now actually present in this contract. And this works exactly as it does in Solidity. So if you had in Solidity all the slots are gonna line up. Now, what's really fun about this is that you can actually annotate this with whatever you like. So, if you wanted to derive something about it, if you wanted to, add other macros, as we're gonna see soon, you can do that. So this is like truly equivalent to a Rust definition. One other fun thing you're able to do, suppose instead of defining it out here, I wanted some things in Solidity and some things in Rust. You can actually mix and match, which is cool. Okay, my editor jumped. So you can actually mix and match. So I could actually define substruct here and, decide to do the same exact thing that we had a second ago. So I would just do a storage bool this time instead of a bool. As I did in the original Solidity example, and everything just works. So you're able to like have this thing connect to this thing. Now, you might be thinking, am I just limited to all the Solidity types? Well, what's actually really cool is under the hood, what this is really using is a type called storage type. So jumping actually into the SDK, I'm going to jump into the storage module. You'll see that there's this storage type that we export. Among many other exports. I won't go into all of them today, but I thought I'd just give a little overview. So this storage type's pretty cool. You don't need to really worry about implementing this, but as I said, this is a bit of a more advanced tutorial, so I just wanted to touch more things than we normally would. And you'll notice that there's a few different things you implement, but what's cool is once you've implemented storage type, you can actually now just go put it in here or put it in here, right? And that is actually really powerful because it means then that somebody could theoretically write a structure for a tree or or some fancy mapping or something that works differently than the default Solidity mapping. You could just do that stuff, and then all of a sudden it becomes connected. So if anybody out there is thinking about like, how do I write a really solid library for Stylus? Well, one thing you could do is create a really cool data structure and provide, the ability for users to import it. And you'll find that there's other types in there and traits that are worth looking at. You'll see that there's the simple storage type. If you're defining a primitive, you'll see that there's I won't get ahead of myself and explain too many things real quick, but, so when I say that Solidity syntax is allowed, it's fully complete. So you're able to do like an array, say, or maybe a mapping of uint to, maybe a mapping of uint to an array of these structures, right? Maybe a fixed array or a nested fixed array. You get the idea, right? Anything that you are able to put in Solidity here, I think you're pretty much able to do here. You're going to run into a couple of things, like right now enums aren't supported, but we're getting there. So, the Stylus SDK is in alpha, but we are introducing new features regularly. And by the time you see this, who knows? It might have even more things that you can play with. But this just gets us started. So, okay, you define some storage, and it can perhaps have various subtypes and nestings and all of that good stuff. Now, what comes next in my contract? Well, once I actually have my contract, I'm going to want to start, creating methods that people are able to use. So normally in Rust, if I wanted to implement something for this contract, I would say impl contract, and then I might define some functions, right? I might say like get owner, and then I'm able to return, the owner or whatever. That's great, but Stylus actually lets us do another thing too, which is I can take this impl block and write at the top external. Now, what does that do? That's telling the Rust SDK and the compiler, it's going to generate a bunch of macros to do all of this. It's telling those things that I want to expose everything in this impl block to the world, so other contracts can call this. So, the way I would architect your program right now is you would have like your private methods, and then you'd have your public methods here. Not to be confused with like pub or pub create or whatever. I'm talking about external or internal, right? So if you want your stuff to be internal, which, if we're talking like Solidity programmers, you'd put your stuff over here, and then the stuff that you want for the whole world to see, you put it in external. And so, we're able to add various methods. So if I wanted to actually expose the owner, I could just define like a get owner method, say, and how this is going to work is we're going to say that it takes a reference to the contract. After all, we're going to need to read the state in order to return the owner. And then we're going to return a result of the thing that we want to produce, so an address. And we're going to actually return an alloy address. Alloy is the crate that provides all of the primitives for Stylus. So we're going to return the address, and right now, a bit of a quirk of the macros is you have to always make it a result. In the future, in the hopefully very soon future, you'll be able to just return an address, but right now, because methods could perhaps fail, you always return a result. And the second entry in the result, the error type, this is just the raw revert data. So it's in the EVM, you're able to return from a call with a successful result or a revert result. And this is what you would put the revert result in. We are right now working on making results prettier and involve like traits and stuff so that you won't have to like have something so verbose right here. But this is just kind of where we're at right now. So we're going to want to return the owner. Well, how do I do that? Contract has an owner. This self, of course, is the contract, right? So I can just return this and clone it. And I'm going to wrap the whole thing in OK because, I'm going to wrap it all in OK because it's a successful thing. So that's just Rust results. That actually allows me to get it. I think actually I need to do get. So that I don't have to have ligatures, I've turned off the actual red underline to see where we have errors. So we might have to check things here and there. But this allows me to This allows me to get the thing that I care about and return it in this result. So getOwner is now callable by the world. Now in Solidity, we have the notion of something being, of something having a purity. We say pure or view or payable, etc. Let's actually export the ABI to see what we have so far. Oh, I suppose before we do that, we need to say that this contract is the entry point. That is that when I want to actually execute the code and I jump into the contract performing an invocation, I want to start, when I start looking at methods, I want to look at the contract object first. If you have several different things that implement methods, as we're going to see later in this tutorial, you might choose to, you have to pick which one of those that you're going to put the entry point on. So one way to do that is just in soul storage, put entry point on the thing that you want to make the entry point. And what's really cool about this is now saying that contract is where we're going to first start looking for methods when we call something. So right now there's only one method in the whole program. So that means that if you didn't specifically call getOwner, it's just going to revert. But that's currently, that's going to become important as we go. So let's go look at the ABI together. So I'm going to go over to my terminal and I'm just going to run cargo stylus export ABI. And after this compiles, we're going to actually see it print out to the console our contract. So I'm going to decrease my size a little bit so that it doesn't overflow. But as you can see here, after some warnings because we didn't use these things, you're going to see here's our interface to this contract. So somebody can actually take this interface and import it into their Solidity project and now work with your contract. We're going to also see later in this tutorial, you can use this interface to call out to other things. So suppose I want to call a contract. How do I do that? Well, I'm going to import its interface and use its methods. But in our case, we're just going to export. So looking at this here, we have our interface. It always prepends it with an I because that's just how Solidity works. And you'll notice in terms of the purity, like I was talking about, this thing is view. Now, why is it view? Why is it the case that this thing is saying, as is defined in Solidity, that I won't modify any storage? That's what view really means. There's some other things there, but that's basically what view means. It knows that that's correct because this is ampersand self. And recall in Rust, you're not allowed to mutate self if you just have an immutable reference to it. Like if I was to say self.owner.set, right? And I started to pass something in. So I don't know, let's say I did address. So this is kind of fun. You can actually import the address macro and I might type in some number or whatever. You're going to see that, let's see here. So, oh, right, yeah, the address macro, I got to actually type out all the stuff. Okay, so we'll just do the 0 type for it. But that can be nice, like if you actually have a, if you actually have a, long address that is constant and you want to call it or whatever. So, okay, right now we're going to see something happens, right? Rust is telling us, you're not allowed to mutate this. This is, of course, just standard Rust stuff, but what's really cool is because the contract has this storage, if I don't have a mutable reference to it, I can't mutate storage. So that means that when we actually export the ABI, it knows that I did a view thing. Now, we can make it something else, right? Let's say instead of view, we wanted to actually be able to mutate state. Well, I can add my anmut self, and currently I'm not actually mutating it, so perhaps I don't need to do that, right? But if we go export the ABI, it says, oh, well, you had access to a mutable reference, so this is no longer view. There are a couple others. There's payable. So if someone was actually sending you Ether and you wanted to actually be able to accept it, you'll notice that that changes the ABI to now be payable. Payable methods are interesting in that you're allowed to accept Ether, and Stylus obeys the same rules as Solidity. So if you try to send money to a function that's not payable, it'll revert. So like if I actually made this payable, I'm not sure why one would pay to get the owner, but you get the idea. I can actually go introspect what that is by calling out to an EVM affordance, calling message value. And my editor auto imported it for me, but you'll actually see here at the top, we've just imported message. Jumping over to message, you can see an example. Actually, here is message value, along with the other things that you're able to detect with this message module. So you'll see we're able to tell if something's reentrant, we're able to say what the sender is, what the value is, etc. And there's various other affordances you can import. There's one for block stuff, there's one for transactions, there's contracts, there's, I don't know, cryptography that you're able to do. There's a lot of good stuff in there, and you just import the specific thing you care about, and then just like you would do in Solidity where you say message.value, you just say message : value. That's saying from this module, I'm going to take the value method. Okay, so that's the various types. And by the way, suppose you didn't want to actually write and itself, but you still wanted the thing to be payable. You're always allowed to use a stricter visibility modifier on something that would auto detect to something weaker. So for example, this thing would detect on its own that, hey, this is an immutable method. But if I actually was to go compile this, you'd notice, look, it says payable. And this just allows you a little more flexibility. Of course, you can't lie. So if I say, hey, this thing is pure, you're gonna notice the red underline there. And if I go try and export it here, you're gonna see that, let's see, oh, here we are. So it's saying that the macros didn't complete, so they didn't, so various other things fail. But the important part is a pure method must not access storage. You'll see that I said the thing was pure, and so, me having this and self thing is kind of a problem, right? So we'll get rid of that. So that's like visibility modification and, actually having that stuff work. So that's visibility modifiers. That's, creating my functions and stuff.